Porting cylinder heads can significantly improve engine performance, but many enthusiasts are discouraged by the high cost and complexity of professional equipment like flow benches. Fortunately, there are practical techniques that allow home garage builders to achieve meaningful results without expensive tools. By focusing on careful observation, basic measurements, and methodical handwork, it's possible to enhance airflow and efficiency. This approach makes cylinder head porting accessible to those working with limited budgets, opening the door to performance gains through resourcefulness and attention to detail. A flow bench has long been a fundamental tool in the process of head porting. Its primary function is to measure the volume of air that can pass through an engine's cylinder head, helping engine builders assess and improve airflow characteristics. By providing precise data on how modifications affect air movement, the flow bench enables more informed decisions during porting. This makes it an essential piece of equipment for anyone aiming to optimize engine performance, as it offers objective measurements that guide both design and technique. Many technology enthusiasts and aspiring builders often face barriers due to the high cost of specialized equipment. These financial constraints can limit creativity and prevent individuals from exploring their full potential. This series is designed to bridge that gap by introducing alternative techniques that rely on more accessible tools and materials. By sharing practical solutions and innovative approaches, we aim to empower builders of all backgrounds to pursue their projects without the need for expensive resources. To get started, you'll need just a few essential tools. Carbide burrs are small, durable cutting tools used for shaping and smoothing metal. A die grinder, which powers these burrs, is compact and easy to handle, making it ideal for detailed work. Alongside these, simple hand tools like files and pliers are also useful. All of these items are widely available and relatively affordable, making them accessible even for beginners. Developing a sense for material removal is crucial when working with carbide burrs. As you guide the tool along the surface, subtle changes in vibration and resistance provide valuable tactile feedback. This feedback helps you judge how much material is being removed and ensures you maintain control throughout the porting process. By paying close attention to these sensations, you can achieve smoother finishes and avoid removing too much material, which is essential for precision work. Velocity sticks and similar simple tools offer a practical way to gauge airflow changes when precise instruments aren't available. By holding a lightweight stick or ribbon in the airstream, you can observe its movement to get a general sense of airflow direction and relative speed. Other methods include using smoke, powder, or even lightweight paper strips to visualize how air moves through a space. While these techniques don't provide exact measurements, they can help identify areas of strong or weak airflow and detect changes over time. Such approaches are especially useful for quick assessments or troubleshooting in the field. When visually inspecting ports, it's important to look for common restrictions such as casting marks, sharp edges, or abrupt transitions that can impede airflow. Areas where the port narrows or where there are visible obstructions often benefit the most from careful hand porting. By smoothing out these imperfections and ensuring a consistent surface, you can help improve the overall efficiency of the port. Pay special attention to the entry and exit points, as well as any sharp turns, since these are frequent sources of turbulence. Identifying and addressing these problem areas can lead to noticeable performance gains. When porting multiple runners, maintaining consistency and symmetry is crucial for achieving balanced engine performance. Each runner must be shaped and sized identically to ensure that airflow is distributed evenly across all cylinders. Inconsistencies can lead to variations in air-fuel mixture, causing some cylinders to work harder than others. This imbalance can reduce overall efficiency, increase wear, and even lead to engine damage over time. By prioritizing symmetry during the porting process, optimal performance and longevity of the engine are better ensured. Seat-of-the-pants testing relies on your own senses and instincts to evaluate changes in your vehicle's performance. Pay attention to how the car feels during acceleration, braking, and cornering, using your butt dyno impressions as a guide. Real-world driving feedback, like noticing smoother throttle response or improved handling, can be valuable indicators of progress. While these methods aren't as precise as professional equipment, they offer practical insights that are easy to gather during everyday driving. Combining your observations with consistent driving routes can help you notice subtle improvements over time. When modifying engine ports, it's important to avoid several common mistakes that can negatively impact performance. Overporting or removing too much material can actually reduce airflow efficiency rather than improve it. Thinning the walls of the ports compromises structural integrity and can lead to cracks or failures under stress. Additionally, creating uneven surfaces disrupts the smooth flow of air and fuel, which can decrease engine power and reliability. Careful attention to detail and moderation are key to successful porting. Several builders have reported impressive power gains using practical techniques, even without access to a flow bench. For instance, by carefully port-matching intake and exhaust components, some enthusiasts have seen measurable improvements in horsepower and throttle response. Others have achieved success by focusing on smoothing casting imperfections and optimizing valve seat transitions. These real-world examples demonstrate that with attention to detail and proven methods, significant performance enhancements are possible without specialized equipment. Such results reinforce the value of hands-on experience and methodical tuning in engine building. Exploring new techniques and materials can lead to surprising and rewarding results in your home projects. Trusting your instincts allows you to discover creative solutions that suit your unique needs and style. By sharing your experiences and outcomes, you contribute valuable insights to a growing community of resourceful home builders. Together, this collective knowledge helps everyone learn, adapt, and achieve even greater success in their own projects. In summary, effective head porting doesn't require expensive equipment or advanced technology. With basic tools, a willingness to learn through hands-on experience, and careful observation of your results, significant improvements can be achieved. The process rewards patience and attention to detail, allowing even beginners to make meaningful progress. By applying these principles, anyone can enhance engine performance through thoughtful head porting.